Hi, it's time for another math easy solution to discuss some derivative examples using the chain rule. This is really important in all of math. I showed this earlier how to derive this, so this is why I think it's useful to understand and learn these examples. Basically, recap on the chain rule: if you have y equals f of u, then basically, and where u is a function of x, g of x, then the derivative in terms of x dy over dx is equal to the derivative of y in terms of u times by the inner derivative d over dx. So this is the chain rule. Now to make it just clarified, use it more often. Let's use it in these examples. Basically, let's go with example 1. It's basically example 1 is fx equals sine of cosine of tan x. Basically a function within a function within a function. So then the derivative, we do the outer one first. Is going to be equal to, well, d over dx. Yes, so d over dx of sine cos tan x. So then we do the outer derivative of sine is just going to equal to, well, it's cosine. We write cosine tan. We just write whatever's inside. And then times by d over dx of cosine. So the next inner function or next outer function, which is cosine. And then this is going to equal to cosine tan x, and then times the derivative of cosine. This is just negative sine tan x times by the derivative of the inside, which is d over dx tan x. Now write this all down. We'll have cosine tan x times by sine. We'll put the negative out here just to make it, just to get out of there. Sine tan x. And then the derivative of tan x is just secant squared x. So there's our answer. And you see my other video on proof of all these derivatives. So basically that's our derivative. It's a bit tedious here, it seems, because yeah, I'm just writing d over dx and everywhere to illustrate the chain rule. But I'll show you in the example 2, we do it all in one step. So e to the sine 3x. It's basically example 2, fx equals e to the sine 3x, and the derivative, well, basically we know the outer derivative is e to the sine 3x, inner derivative sine 3x, and the innermost is 3x. So the derivative of the outermost, e to the sine of anything, e to the anything is just itself, so e to 3x. And then we do this next inner one, sine. The derivative of sine is just cosine 3x, and then the derivative of, well, 3x is just 3. So there's our derivative. That's all we do in one step. It's really quick and easy. So yeah, in example 3, now this one we actually use a chain rule and the actual the quotient rule, if you remember that from other video. In this basic example 3, fx equals x minus 2 all divided by 2x plus 1 to the power of 9. So the outer function, if we do the derivative again, is, well, outer function is the power 1, which is this to the power 9, and the rule for that is just basically put the 9 down. And then we have x minus 2, 2x plus 1 times it by, well, 8. And then this one, if you remember the product rule, then we times the inner one. We use the product rule. The derivative of this one is going to be, well, the derivative of the top, which is 1, times the, whatever the, times by denominator, and then subtracted by derivative of the bottom, which is 2, and then times by the numerator, which is, well, x minus 2. Then all this is going to be divided by the denominator squared. So basically, if you simplify all this one out, this top here is going to be equal to, well, I'll just write this top one here is going to equal to 2x plus 2 minus 2x plus 4. And this cancel, these add up. Actually, I mean, yeah, this is 1 plus 1 times 1, so not plus, so this is a 1, not a 2. So this one we're left with, yeah, so then this one adds up to 5. So we just simplified the top part, so we're left with basically 9 times x, 2x plus 1, power of 8, times by 5 over 2x plus 1 squared. And these are this is plus 1. So 9 times 5 is 45. So we're going to be 45 times, well, the bottoms are the same, so that we're just going to have x minus 2 to the 8. And then this one, we just put them together. It's 2x plus 1 to the power of 10. So we put these together, this is 2. That's the power of 8. So basically that's our derivative. Yeah, so that's our derivative. So now let's look at example 4. So example 4 is we're going to use the product rule and the chain rule at the same time. So 2x plus 1, 5x, whatever. Yeah, so example 4, fx equals 2x plus 1 to the power of 5 times x3 minus x plus 1 all to the power of 4. So this one we're going to use the product rule. Remember the product rule in my other videos? Basically f of x is going to be equal to, well, derivative of this one here. This is going to be equal to, well, 5 times by 2x plus 1 times it by, this is 4, then we times the inner of this one. So remember we have two functions times each other. So do derivative of this part right here first. Then, yeah, so this one's going to, then we do chain rule here. So this is 4 times derivative of 2x plus 1, just 2. Then we just times it by x3 minus x using the product rule. And then we all add this up. We just add it towards the derivative of this one here. So we just first times this one out. Times by derivative of the outer one, which is just using the power rule. This one's put the 4 down. x3 minus x plus 1 power of 3. And then this one is just going to be times by the derivative of the inside, which is 3x squared minus 1. Yeah, so in this one we could simplify it more somehow, but this is already complicated enough, and if you're doing a calculus exam, you can just leave it as that, you'll get the right answer. Basically, just to recap on this one, basically what you do is fx, using the product rule, will do d over dx of, just to recap what I did here, it's a bit complicated. Basically, the product rule is the derivative of this one times that plus the 2x plus 1 times the derivative of the other function here. And then we just do the same chain rule what we've been doing before. Well, that's all for today. Hopefully you learned these. These are some useful examples. Make sure you understand how I got these all. Because, yeah, once you do, it'll be really easy on your exams and whatnot. Well, thanks for watching, and stay tuned for another math easy solution.